Welcome back. Today we're going to talk about rate of change. Okay, so rates of change are sort of an answer to a question. So sometimes when we're looking at two graphs, so for instance, if I have graph number 1 and graph number 2, my question might be, how fast are the variables changing? Like, what's a way to compare these two graphs? We can sort of intuitively see that this line is steeper than this line, right? Or this line appears to go up faster than this line. And that's just, looking at it geometrically, we can see this one appears to achieve a higher height for, let's see, an x value of 2. This one has a height of 4 for an x value of 2, whereas this one has a height value of 2 for an x value of 2. So we can see that, quantitatively it appears that it's going up faster, and just to our eyes, geometrically, it looks like it's going up faster because it looks steeper. All right. So to answer a question like how fast the variables are changing, we're going to compute something called the rate of change, right? So it makes sense that it's called the rate of change because it's the rate at which the graph is changing, right? Or the rate at which the variables are changing. So the rate is a ratio, right? Ratio meaning fraction of the amount of change in the dependent variable or the output variable to the amount of change in the independent variable or input. So think about the way that I've just phrased that. So it's a ratio of, remember, right when you see of, you know that the next part is going to be the numerator, the amount of change in the dependent, so that becomes the numerator. And then when you see 2, the next part is going to be the denominator, the amount of change in the independent variable or the input. So the rate of change is a fraction or a ratio of the change in the dependent over the change in the independent. Okay, let's just review what a rate is for a second so that we can sort of break down rate of change. A rate is a specific ratio or fraction where the units in the numerator are different than the units in the denominator. Okay, and so we can see rates in things like a very classic rate is speed, where you have miles in the numerator, and you have miles. So you have miles, and then you have so you have some sort of distance measurement and some sort of time measurement. So this is a rate because the units in the numerator are different than the units in the denominator. So our rate of change is going to be a rate because the units in the numerator are going to be the change in the dependent or the y variable versus the change in the independent. So it's just a measure of the two different changes that we're looking at. Okay, that's why it's called a rate of change. You're making a rate out of the two types of changes that are occurring in the graph, the y variable change versus the x variable change. And we're going to use rate of change all the time in order to compare graphs. And also in order to compare tables or functions just written out verbally. So here we have a table. So we're going to look at the rate of change. So it's not graphed right here, but that's totally fine. We're going to be able to compute the rate of change perfectly fine from a table. So the first thing we want to do, because it's a ratio of the dependent versus the independent variables, we're going to have to identify which is which. Okay, so remember when you do this, you want to think about something depends on something else. So think about the sentence that we talked about in the last lesson, right? So for me, let's think about the number of lawns depend on the amount of money earned. That doesn't seem right. So the money depends on the lawns. Okay, so that statement is the correct statement. The amount of money that this young woman earns depends on the amount of lawns that she mows. Okay, so money will be the dependent or the y variable, and the amount of lawns will be the independent or the x variable. So I can mark it as independent or dependent if I want this way. Okay, so to find the rate of change is the change in the dependent versus the change in the independent. Now to mark change, I'm going to have to actually pick 2 points here. Okay, so these are actually 2 points. This first point is 1, 15, and the second point is 3, 45. Okay, if I'm writing it in terms of x, y, which is how we write points. Okay, so what I want to think about is, even without writing these points, I can just pick the change off the graph here. So between these 2 points, the amount earned increased by 30, and the amount of lawns mowed increased by 2. right? So we went from 1 to 3 and from 15 to 45. So we're going to make a ratio of this change. So it's going to be the change in the dependent versus the change in the independent. Okay, so it's 30 over 2. I'm actually going to move this over here because I'm going to compute all of the rates of change. And that reduces to 15. Okay, let's do it for the next one to see if it's different. This right here is a change of 45 versus a change of 3. Okay, that would be 45 divided by 3, which is 15. So that gets the same thing. Notice this is not, there's similarities with the constant of proportionality and there's differences. Okay, the similarity is that it's the y over the x, but the difference is that we're marking change. It's not just the y over the x, it's the change of the y variable over the change of the x variable. Okay, that's how it's different from the constant of proportionality that we learned about yesterday. Okay, and so let's do another change here. The difference between here is 30 and the difference between here is 2. So again, we have 30 over 2, which is 15. So all the rates of change between the y variables versus the x variables are 15. Okay, so they're all constant rates of change. Okay, so let's review how to find a rate of change, or let's learn how to find a rate of change from another table. So the table below shows the appropriate height of a football after it's kicked. Tell whether the rates of change are constant or variable. Now, in our previous example, they were all constant. So here the rates of change were constant here. They were always 15. Let's see if it's the same for this table here. Okay, so first thing we have to do is identify the independent versus the dependent. Now, something depends on something else. Does the time depend on the height, or does the height off the ground depend on the time? I'm going to say that the height off the ground, right? So if they kick a football, it goes in this trajectory. The height, so if I'm measuring height off the ground by just looking at, okay, if the football is here, I'm measuring this is the height off the ground. If this is the height off the ground, then, which it is, then it's going to depend on the amount of time after which the football has been kicked. Okay, so that means that this is the y variable and this is the x variable. Now you want to be careful because sometimes they do put the table so that the y variable is on the left and the x variable is on the right. So don't make a solid rule that like x is always going to be in the left and y is always going to be in the right, because rules like that are really meant to be broken. Which is to say that if you see it on a test, it's, sometimes it may be reversed. So always go through your sentence to try to figure out what's dependent and independent. Okay, so let's pick two points here because we're marking change, right? We're not doing x over y. We're looking at the change of y over the change of x. So here, this increased by 18. So I'm going to write positive 18. From 0 to 18, that's an increase of 18. From 0 to 0.5, that's an increase of 0.5. So our first rate of change is going to be 18 over 0.5, so that's going to be 36. 18 divided by half is 36, right? That's how many halves are in 18? There are 36. You should remember the keep, change, flip rule for dividing a whole number by, essentially, this would be a fraction. This would be 18 divided by 1/2, which would be 18 times 2, which is 36. Okay, so that's the first one. That's the rate of change between the first two is 36. Now let's pick the next one. Okay, between 31 minus 18 would be 13, and between here that would be 1, right? So 1/2 minus 1/2 would be 1. So that would be 13 divided by 1, which is 13. So already we can see that this was the rate of change between the first two time and height combinations, and this is the rate of change between the next two. Okay, so already we can see that it is not constant because these two numbers are not the same. So I don't even have to continue because I've answered my question. The rate of change is variable, or the rate of change is changing. All right. So I've answered my question there. So the one that we just saw, the rate of change was constant. This one, the amount of Lon's mode, but the one that we saw here is variable. Okay, now let's view, and in the next lesson, by the way, we're going to talk about what the graph looks like when the rate of change is constant and what it looks like when the rate of change is variable. But the first step is deciding whether it's constant or variable. Remember, variable means changing. Okay, so let's find the rate of change from a graph. All right, it's a little different from the other examples because we're not using tables. All right, we're going to identify the independent versus the dependent. So the independent is the y and the dependent is the x. So the independent is the distance that Nathan bicycled over time. And the dependent, the independent is the time and the dependent is the distance. So the distance that he bikes depends on the amount of times that he's been biking. Okay, now let's find the rate of change here. So let's think about between, we're looking at the change of the y coordinates between these two, or the y variable between these two coordinates. So between 30 and 15, it would be 15 points, okay? And the change between the x variable would be 1. So from 1 to 2, that's a change of 1 unit. So it's 15 divided by 1, which is 15. Okay, let's see if it's the same between the next two. 45 to 30 would be 15, and 2 to 3 would be 1, so it would be 15 over 1, which would also be 15. And the same would go here. This would be a change of 15 between 45 and 60, and a change of 1 between 3 and 4. So again, it's a constant rate of change, right? It's 15, 15, 15. It's constantly the same. And so it's constant, it's not variable, and the rate of change is 15, okay? Now, how do we know it's always going to be constant? Well, in the next lesson that we look at these, we're going to look at what the graph of the function looks like when the rate of change is constant. So we don't entirely know, like, what if the next point makes it so that it's not a constant rate of change? We're going to deal with that in the next lesson, all right? So at the end of the lesson for today, you should be able to understand what the rate of change is, and you should be able to calculate it from a table and a graph. And that's it for today.